Good morning, this is Kasturi Day. Today I'm going to start with the heat transfer chapter according to ICSE syllabus class 8. Okay, so this chapter will deal with the transfer of heat in solids, liquids, and gases. Okay, so first we start with the introduction. Say matter. Matter is composed of tiny particles. We know they are called molecules. Okay, the molecules of a matter are in a motion, as well as they have forces of attraction amongst them. We know they have forces of attraction, they have attractive forces. Okay, and the molecules, they have kinetic energy because they are always in motion. So the molecules, they have kinetic energy due to their motion and potential energy due to their state of position. Now the solid state have greatest, that is the potential energy in the solid state is maximum, and they have least kinetic energy because the solid molecules move very little. The motion of the solid molecules is very less. The gaseous state, they have just the opposite, like the solid of the solid, that is the gaseous state have least potential energy and greatest kinetic energy. Now internal kinetic energy and internal potential energy, when we sum these two, that is when we add these two, that is the internal kinetic energy plus internal potential energy, we get the internal energy or heat energy of a substance. Okay, so heat, what is heat? Heat is the internal energy of a substance and measured in unit joule. We measure the heat in joule. Okay, when two bodies are kept in contact, heat flows from the body at high temperature of the body to a low temperature. Okay, uh, so heat is measured in unit joule, and when two bodies are kept in contact, heat flows from high to low. Okay, high to low. Then the average kinetic energy of a substance is measured in temperature. Okay, and this when there is a rise in average kinetic energy of a molecule, the average kinetic energy of a substance is the measure of a temperature of it. Okay, what is the average kinetic? It is the measure of temperature. How much temperature it is, that will be the kinetic energy, average kinetic energy of that substance. When there is a rise in average kinetic energy, when there is an increase in the average kinetic energy of the molecules of the substance, its temperature increases. Okay, so when there is rise in average kinetic energy, the temperature increases, and when there is a fall in the average kinetic energy, the temperature decreases. Okay, so uh, then but during the change in the state of a substance, when the substance state changes, that is from solid to liquid or liquid to gas or gas to solid, gas to liquid, like that, when there is a state change, then the temperature becomes constant. Okay, there is no change in the average kinetic energy of the molecules. Okay, then we come to the effects of heat. Okay, so what are the effects of heat? Due to the heat, there is a change in temperature of a body, there is a change in the state of the body, and there is a change in the size of the body. Okay, now what is the change in temperature of the body? What happens when there is a change in the temperature of a body? When a body is heated, what happens? Its temperature rises, and when it gets cooled, its temperature falls. Okay, so when there is a change in the temperature of the body, that means its temperature either it has risen or it has come down. So when it is heated, its temperature rises, and when it is cooled, its temperature falls. The change in temperature for body depends on the following two factors, that is quality of heat imported or to or rejected from the body. Either the quantity of heat, either it has been absorbed or it has been rejected by the body when heat is imported or given to a body. When heat is being given to a body, either it has absorbed the heat or it has rejected the heat. Okay, its temperature rises when heat is rejected or taken from the body. Okay, when heat is taken from a hot body, then what happens? The temperature of this body, it rises. Okay, and I'm sorry, when the heat is imported or given to a body, its temperature rises, and when it is rejected or taken away from the body, then its temperature falls. Okay, so what happens when the quantity of heat is being given to a body, and when the heat is given to a body, is imported to a body, then the temperature rises, and when it is rejected by the body or taken from the body, then its temperature comes down. It's so because on heating the molecules begin to move faster. Okay, they gain kinetic energy. Average kinetic energy of the molecules increases, and so it starts moving faster. And so what happens? They move faster, so the average kinetic energy of the molecules decreases, and so the temperature falls. Okay, I'm sorry, there is some mistake in this, because the molecules, when they move faster, the average kinetic energy increases and the temperature rises. And this happens when the body is cooled. When it's the temperature, heat is given out or heat is rejected, what happens? The kinetic energy of the molecules decreases, the average kinetic energy decreases, and so the temperature falls. Now, it again depends on the material of the body. Okay, so when some materials rise to a high temperature, while the other so the temperature while they rise to a low temperature even when same quantity of heat is given to them. Okay, when same quantity of heat is given to them, some they gain more temperature and some they gain. Okay, it is so because different materials have different specific heat capacities. That is, what is specific heat capacities? It's different amount of heat required to raise the temperature of unit mass by unit rise in temperature. Okay, so that is the specific heat capacity. So the due to as the different materials have different specific heat capacities, so what happens? Different materials, they when the heat is same quantity of heat is given to them, two different materials will have different rise in temperature. Okay, next is a change in the state of body. Matter exists in three different states: solid, liquid, and gas. The process of change from one state to another at a constant temperature, this is known as change of state. So from one state to another, it is from one solid to liquid, or liquid to gas, or solid to gas, or gas to liquid, liquid to solid. Okay, like this, there's a change of state. So from one state to another at a constant temperature, this process is known as change of state. So when a solid is heated, it changes into liquid at a fixed temperature. That is known as melting. Okay, when a liquid is cooled, it changes to a solid at the same fixed temperature. That is known as freezing. So, for example, ice melts into water at 0 degree centigrade on heating, and water freezes to ice at 0 degree centigrade on cooling. Okay. So when a liquid is heated, it changes into vapor or gas at a fixed temperature. That is known as vaporization or boiling. When the vapor condenses, it changes into its liquid at the same temperature. That is known as condensation. Okay, so the opposite of boiling or vaporization is condensation. For example, water on heating, it vaporizes into steam at 100 degrees centigrade, and steam on cooling condenses into water at 100 degrees centigrade. Then when a solid on heating changes directly into vapor without melting, without becoming liquid, it directly into gas, it changes at a fixed temperature, that is known as sublimation. Okay, see, in all these cases the temperature remains constant. In all these change of state, the temperature remains constant. Okay, here in the case of C, third case, that is these vapors on cooling change directly into solid state. Okay, like when a solid changes directly into vapor, and again the vapor changes directly into solid without becoming liquid. This is known as solidification. When vapor changes directly into solid, that is solidification or deposition. For example, camphor on heating changes directly into from solid to vapor. Again, fourth case, again the change of state from liquid to gas at all temperatures. Liquid to gas at all temperature, that is known as evaporation. For example, drying of clothes. Okay. See, so during the change of state, the heat is absorbed, or either it is absorbed or rejected. So this is known as latent heat or hidden heat, you can say. It is so called because it is not manifested by any change in temperature. Here, this it is called latent heat or hidden heat because there is no change in temperature occurring in this change of state. This latent heat, when when expressed for unit mass of a substance, that is known as specific latent heat. Okay, the latent heat does not raise the chamber, but raise the temperature, but changes the force of attraction between the molecules of a substance. Okay, since the temperature remains constant, the absorbed or rejected heat has no effect on the speed or the average kinetic energy of the molecules. So during interconversion of states, the latent heat increases or decreases only the average potential energy of the molecules, whereas the average kinetic energy remains unchanged. Only the average potential energy that changes of the molecules that changes during this latent heat when it is increases or decreases, but potential energy, average kinetic energy remains unchanged. Okay, so I'll stop here. I'll continue with the rest of the chapter in my next video. Okay, so please go through this. Hope you are liking the videos. I'm tried a new process, a new way out to make it more interesting. Okay, so that you can understand it better. Please press the like button and also do subscribe to get the notification of my next video. Okay, and I'll be soon launching a website which will contain much more information on your science subjects as well as on different other subjects also, and some more interesting things which you can see in the website. Okay, so please wait for that, and please do watch my videos. Thank you for watching.